Alright, the rules for multiplying and dividing radicals come directly from when we simplify radicals and when we take the square roots of fractions. So let's just review how we did that. Let's say we had the square root of 72 and we want to simplify that radical. Well, what we would do there is express radical 72 as radical 36 times 2, which we can express as radical 36 times radical 2, which is 6 radical 2. So when you're multiplying radicals, right here, this is a multiplication of two radicals. So if we are able to go down this way to express radical 72 as radical 36 times radical 2, then that means we can express radical 36 times radical 2 as radical 72. And that's exactly how we're going to multiply radicals together. We're just going to make it one radical. We're just going to multiply the radicands together and make it one square root term. So for example, if we had radical 3x to the third times radical 6x squared, all we're going to do is multiply our radicands together and make it one radical. Radical 18x to the fifth. Now the only problem is we just have a little bit of simplifying to do. So let's express 18 as 9 times 2, and let's express x to the fifth as x to the fourth times x. Just a little shortcut when you're simplifying variable radicands. If it's odd, you're always just going to leave one behind. If it's even, it's already a perfect square, so leave it alone. So x to the fifth, I just express as x to the fourth times x to the first. If it were x to the seventh, I would say x to the sixth times x to the first. You're just going to leave one behind. Now we can circle our perfect squares. The square root of 9 is 3. The square root of x to the fourth is x squared. And we're left with a 2x in the radicand. So, radical 3x to the third times radical 6x squared is 3x squared radical 2x. Let's work on another multiplying question. Let's say we have 32 radical 32a to the fifth times radical 12a squared. Now before, we could have simplified the x to the third first, we could have simplified the x squared first, but the 3 and the 6 are pretty easy to work with. Now instead of multiplying 32 and 12 together, I could do that. But what I'm going to do here, because we're working with larger numbers, I'm going to simplify them first, and then I'm going to multiply. So let's express radical 32 as 16 times 2, and let's express the a to the fifth as a to the fourth times a. And that's all being multiplied by, let's express radical 12 as 4 times 3. And a squared is already perfect square. So I'm going to leave it alone. Now we'll circle our perfect squares. 16, a to the fourth, giving me a 4a squared on the outside and a radical 2a on the inside. Times, circle our perfect squares. Square root of 4 is 2. The square root of a squared is a. And we have a radical 3 left behind. Now, there's no operation connecting these two things, which means it's being multiplied. So it's 4a squared times radical 2a times 2a times radical 3. So this is all being multiplied. So I can change the order without changing the product. So let's multiply our coefficients. 4a squared and 2a is 8a to the third, and radical 2a times radical 3 is radical 6a. It's really as simple as that. To multiply radicals, make it one radical. Or simplify them first, multiply the coefficients, multiply the radicals. Either way, you end up the same thing. If I had multiplied radical 32, a to the fifth, times 12a squared, it would just have a larger number to simplify, but I'd end up with the same solution. So just to divide some radicals, when we took the square root of some fractions, let's say we had radical 100 over 16, and I wrote that a little small, so let's say I had radical 100 over 16. Well, then we had the ability to say radical 100 over radical 16, which is 10 over 4 simplified to 5 over 2. So the story here is, this is a division of two radicals. If we're able to express radical 100 over 16 as radical 100 over radical 16, then we have the ability to make a quotient of two radicals one radical, just like we did with multiplication. So some examples. Let's say we had radical 72x squared over radical 2x. Two ways I go about this. I could make it one radical immediately, or I could simplify the radicals first. It depends what the question entails to determine what the best method will be, because sometimes it'll help to simplify it first, and sometimes it won't. In this case, I could just make this one radical first, and look how easy this becomes. Radical 36, and I have an x squared over x over here. All I did was divide the 72 over 2. I could have said 72 over 2, but that's 36. X squared divided by x is x, and the square root of 36 is 6. So I'm going to leave this as radical 36x, and then take the square root of 36 for 6 radical x. Now, if I had simplified this first, let's provide a parallel solution. Let's express 72 as radical 36 times 2 times x squared over radical 2x, where the square root of 36 is 6, and the square root of x squared is x. So I could say 6x radical 2 over radical 2x. All the 2's cancel here, and I have radical 6x over radical x. So I'm going to wait to solve this for, I think it's Thursday, when we begin what's called rationalizing denominators. But for now, I would leave this as, let's see, we would have the radical 2 cancels with the radical 2, so we have 6x over radical x. So I'm going to leave that for now. In the future, we will not allow to have a radical in the denominator, but for now, we don't have a method to clean that up. Alright, another example. Let's say we have 4y radical 30 over 2y squared radical 12. Again, I could go about this by simplifying the radicals first, but I could just make this one fraction, and I could divide my coefficients right away. If I divide my coefficients right away, I could cancel the 2 with the 4, leaving me with the 4 in the numerator. I could cancel a y with the y squared, leaving me with the y in the denominator. So I'm going to do that first, before I even divide these things. I'm going to say 2 over y radical 30 and radical 12. This just makes my whole life a whole lot easier. I don't have to worry about all those extra terms as a coefficient. So now what I could do is simplify both of these radicals completely. So if I wanted to express radical 30, that is already in simplest radical form. There's no way to break down radical 30, because the factors of 30 are 15 and 2, neither perfect squares, or 6 and 5, neither of them perfect squares, or 3 and 10. So there's no perfect square factors of 30. There are perfect square factors of 12. So I can simplify that. But in order to do this, what I'm going to do is just make it one fraction and simplify the fraction. So 30 and 12 have common factors of 2. So I'm going to divide both of them by 2, giving me 15 over 6, and then I'll take the square root of the numerator and denominator separately, just like this were a fraction. Well, it is a fraction. 2 radical 15 over y radical 6. And for now, that's all we can do. In the future, we're going to have a way to treat that, but for now, this is how we're going to leave it.